All right. Our next section that we're going to cover is section 1.3, more data collection, but also talking about experimental design. So designing a statistical study. Before we can actually design something, we have to identify the variables of interest. What will the focus be and what will the population be? Determine a detailed plan for collecting the data. How are we going to collect the data? We want to make sure that if we can't get the population, the entire population, then is a sample necessary? And if so, how do I pick that sample? Then I'm going to collect the data. I'm going to describe it using descriptive techniques. I'll interpret it and make decisions using inferential statistics, and then identify any possible errors. So, in an observation study, a researcher observes and measures characteristics of interest of part of a population. For example, researchers measured the amount of time people spent doing various activities such as paid work, childcare, and socializing. So this is just an observational study. Because you're not really doing anything but, like they said, observing, measuring, finding out what people are doing. In an experiment, a treatment
is applied to part of the population, which is called the treatment group. Then those responses are observed. Another part of the population is considered the control group. You've probably heard of these. This is often the case in medical treatment, where we have a treatment group and a control group. So there's no treatment applied to the control group. The subjects in both groups are called experimental units. And in many cases, subjects in the control group are given what's called a placebo. And again, you've probably heard these talked about in healthcare particularly. So it's a harmless fake treatment that is made to look like the real treatment. For instance, an experiment was performed in which overweight subjects were given the artificial sweetener sucralose to drink while the control group drank water. While performing a glucose test, researchers concluded that the sucralose affects the glycemic and insulin responses in overweight people who do not normally consume artificial sweeteners. So you have a placebo that's given to one control group, while the other experimental group or treatment group actually gets whatever the treatment is, and then as a result of those two groups, you get to make some conclusions. So example 1 says to determine whether each study is an observational study or an experiment. Researchers study the effect of vitamin D3 supplementation among patients with antibody deficiency or frequent respiratory tract infections. 70% receive 4,000 IU of vitamin D daily for a year. Another group of 70 patients received a placebo. So this then should be, and is in fact, an experiment. There are 70 patients in the treatment group, 70 patients in the placebo group, and their treatment is actually the vitamin C. I'm sorry, vitamin D. No conclusions were mentioned in this case, so we don't know what the results were, but we don't have to just to determine what kind of study it is. So number 2 says researchers conduct a study to determine how confident Americans are in the economy. Researchers call 3,040 U.S. adults and ask them to rate current economic conditions and observe whether the economy is getting worse or better. So we're asking their opinion. We called 3,040. We asked them basically their opinion, rate the economic conditions, and if the economy is getting better or worse. So this would be an observational study. You don't have a control group. You're not performing an experiment on treatments. Instead, you're just looking at answers that people give you. A lot of statistics on that, and this is election results and that kind of thing, and making predictions based on that.
All right, some additional data collecting then. So this first one is a simulation. And a simulation uses mathematical or physical models to represent certain conditions in a situation or a process. It often involves the use of computers. It allows you to study situations that are impractical or even dangerous to create in real life. They often save time and money. And for an example, automobile manufacturers use simulations with test dummies to study the effects of crashes on humans. Well, obviously you don't want to have crashes on humans, so using the test dummies allows the manufacturers to check on the effects of car crashes from different sides at different speeds without harming humans. That would be a simulation. A survey is an investigation of one or more characteristics of a population. They're carried out on people by asking them questions. They are commonly done in an interview, internet, phone, or email, or regular mail. In designing a survey, it's important to word the questions so that they don't lead to biased results, which are not representative of a population. And for instance, a survey is conducted on a sample of female physicians to determine whether the primary reason for their career choice is financial stability. And in designing a survey, it would be acceptable to make a list of reasons and ask the individuals in the survey to select their choice. So oftentimes you will see choices for people to select. And sometimes there's an NA or not applicable to in those choices. So for an experimental design, then, the next section says there are 3 key elements of a well-designed experiment called control, randomization, and replication. A confounding variable a confounding variable occurs when an experimenter cannot tell the difference between the effects of the different factors on a variable. For instance, a coffee shop owner remodels her shop at the same time a nearby mall has its grand opening. If business of the coffee shop increases, it cannot be determined whether it's because of the remodeling or because of the new mall. So that would be something that confounds the situation. The placebo effect occurs when a subject reacts favorably to a placebo when in fact the subject has been given the fake treatment. And so sometimes this happens when you're doing experiments and it looks like the placebo actually did something when in fact it's just perhaps coincidence as to how the effect happened. So to help control or minimize the placebo effect, a technique called blinding can be used. Blinding is a technique where the subject does not know whether he or she is giving the experiment treatment or placebo. In a double blind, experiment, neither the subject nor the experimenter knows who is receiving the treatment and who is receiving the placebo. And to help with this too then, we also use randomization. Randomization then is the process of, again, randomly assigning subjects to different treatment groups. So completely random whether or not you get the treatment or not. In a completely randomized design, subjects are assigned to different treatment groups through random selection. So literally just randomizing. The first person who comes in goes to one side, the second person goes to the next side, and you never know for sure who is going to get the treatment. So to use a randomized block design, the experimenter divides the subjects with similar characteristics into blocks, and then within each block randomly assigns them to a treatment group. So for instance, an experimenter testing the effects of weight loss drink may divide the subjects into age categories. Then within each age group, they randomly assign whether or not the treatment group is, whether or not which people are in the control group, which people are in the treatment group. So this will allow us to have 3 different age groups. And within those 3 different age groups, we now have a control and a treatment group for each one. And that will give us a little bit more data because perhaps the 50-year-olds don't react as well as the 30-year-olds. So this will give us a little bit better opportunity to break the data up even more, see what we can do from there. All right, another type of experimental design is called a matched pairs design. And this is where subjects are paired up according to a similarity. One subject in the pair is randomly selected to receive one treatment while the other one receives a different treatment. Sample size is going to be important, and you'll see soon why sample size is important. But that's the number of subjects in a study, and it is very important to the experimental design. To improve the validity of experiment results, we also replicate the experiment. And so all of this is to help us get a better design in our statistics. You've probably heard before you can get your statistics to say just about anything you want them to say, and that is true. And in something like whether or not people think the economy is good or bad, may not have near the effect of somebody who's in a medical study and we're trying really to find a treatment that works. So every time we talk about doing a statistic or doing a design, an experimental design, we need to make sure that we have a good plan in place so that we know what we're doing is going to make a difference. When it's very important, like in medical cases, we want those statistics to really benefit the subjects. Replication, of course, is just repeating the experiment on several groups of people or several times. So, for instance, to test a vaccine against a strain of influenza, 10,000 people are given the vaccine and another 10,000 are given the placebo. The sample size, the effectiveness of the vaccine would most likely be observed. And so, again, we want to have enough people that we can find whether or not it's really effective. And so if we did that and decided that 10,000 people weren't enough, we could replicate it again and do another 10,000 people in the next one. All right, so let's look at some practical examples then. Number 1, a company wants to test the effectiveness of a new gum developed to help people quit smoking. Identify a potential problem with the experimental design and suggest a way to improve it. So it says a company identifies 10 adults who are heavy smokers. 5 are given the new gum, 5 are given the placebo. After 2 months, the subjects are evaluated, and 5 subjects using the new gum have quit smoking. So this sounds like it's great results. It sounds like things are going really well.
So if you were to stop right there, then this company might say, hey, this is 100% effective. Everybody who was given the gum quit smoking. So although you do have great results, which is nice, those results are based on such a small sample size that it's really not large enough to make that distinction that it is 100% effective. So it has great results, but again, the sample size is too small. And in this case, I would say it was way too small, because again, 10 people really doesn't give the results that will give us any indication as to whether or not it really is effective. One way to help predict this would be to increase the sample size and also then replicate the experiment again and see whether or not you get the same results. And that should help improve your validity. So we're going to replicate to improve validity.
All right. Second example says, the company identifies 1,000 adults who are heavy smokers. So that's good. That's getting us a little bit more adults involved. So now we're up to 1,000. The subjects are divided into blocks according to their gender. Females are given the new gum and males are given the placebo. After 2 months, the female group has a significant number of subjects who has quit smoking. So again, 1,000 adults, so that's better. They're split into blocks according to their gender. The problem here, though, is that the females are the only ones given the gum, and the males are the only ones given the placebo. So what's going to be hard to say is, does the gum really help everyone, or does the gum only help female? So again, male and female is good, but within that male and female, the better design plan would be to have a control group and an experimental group. So again, the control group would be given the placebo, and the experiment group would be given the gum. Now you're going to have better results because we'll be able to determine whether or not the gum affects male and females the same way. So now we know that this is going to help more than just the fact that maybe females have a higher desire to quit smoking. There's no way to know for sure whether it's the gum or is it just that females worked harder to quit smoking. It's hard to say without having a control group and an experimental group. So that would help fix it. Also remember, if we are going to do these two control groups, we do want to randomly assign them. So you want to randomly assign which males get the control group and which males get the gum, which get the placebo and which get the gum. This way it's all randomly done. All right, next section. Next section talks about some sampling techniques. So different ways that we can get the sample size we want, or how we can do some sampling. One way is with a census. Census is a count or measure of an entire population. A sampling, then, is a count or part of the population. So when we do the census every 10 years in the United States, the hope is to get the entire population. Where if we're going to do a sampling, then that's going to be more commonly used because now we don't have to pick the entire population. We can look at just a piece of that. However, with that sampling also comes a sampling error. If you're only picking one county in the state of Texas to do your sampling, then that may not be indicative of the entire state of Texas. So if you're looking at perhaps a political race, then again, looking at one county won't give you the results where you could make conclusions about the entire state. And that would be an error in the way you sampled. The actual error is a number, and it's the difference between the results of the sampling and those of the population. A random sample is one in which every member of the population has an equal chance of being selected. A simple random sample, it's a lot, simple random sample, is a sample in which every possible sample of the same size has the same chance of being selected. Random numbers can be used to generate this using the calculator, which is going to be the first time that we are going to put in your calculator. Basically, a random chance of being selected really is, I'm going to take every fifth person who walks into the grocery store. Then you're looking at the fifth person who walks in and then the 10th person. Or you might say, I'm going to let truly randomized numbers pop up on a calculator or on another method that will allow us to know exactly who to choose for the sample. So to help us with that, we do have the TI-84 calculator. And so if you open the calculator, the directions here will tell you how to do your calculator. There are two, so it depends on which version of the 84 calculator you have as to exactly what this looks like. So it's not unusual. You'll need to get your calculator and play with your calculator and see. If you have an 83 or an 83 plus, again, the buttons will be very similar when you push the buttons, but you just need to practice before you get ready for a test so that you know for sure what you're looking for. So to find a sample using random numbers, we're going to select the probability menu, which on my calculator, I hit stat. Oops, sorry. Sorry, we're going to hit, let's clear that, instead of, whoops, yeah. Clear here, sorry. Okay, so instead of hitting stat, we're going to hit the math key, which is right here. And now we have across this top menu, we have a number key, we have complex numbers, we have probability, and we have fractions. We want to look at the probability. So we're going to tab over until we get to the probability. Once we get to probability, we're going to go down to the random INT, which is number 5. So you can tab down till you get to number 5. You can also hit the number 5. And when you do that, we're now going to hit enter in the calculator. And this is where, again, depending on the calculator version you have, it might go directly to a home screen looking menu, which is like what this looks like right here. This is actually your home screen. Or it might give you this menu, which tells you to go ahead and enter in the numbers. So my calculator says I want an upper bound and a lower bound. So looking at this example, it said we were going to sample 731 students currently enrolled in a stats class. You wish to form a sample of 8 students to answer some survey questions. So the lower limit would be 1. The upper limit would be the 731 students. N would be the number that we want to randomly pick. In this case, we want to pick 8 students random. Then I'm going to go down, and then notice that paste is being highlighted. That means, yes, I'm ready to paste. So if I hit enter again, now I get what looks similar to the home screen menu on the other one. So it's just the way the data is entered. And then if I hit enter again, that now gives me 8 random numbers: 690, 664, 108, 377, 297, 835. And if I go up, I can tab over and get the other numbers. Now let me tab here on this calculator. If I want to do this again, there's a couple of features on the calculator that make it really nice. Since I want to do this again, if I hit the second enter button, that will show me what I picked last time. So the second enter gives me the menu before. And if I hit enter again, notice that I still get 8 random numbers, but they are different random numbers. If I want to do the experiment again to get 8 different people, again I can do second enter, hit enter again, and I now have person that's numbered 79, number 5, number 402, and I can get the rest of them. And again, if you see that this little arrow is here, that means that there is additional information over there. And so if I tab over, oh yeah, it tabbed. So there's 1, 2, 3, 4, 5, 6, 7. And then the 8th person would be brought to the side. I'm not sure why it won't let me tab over, but on your regular calculator you should be able to tab over using this button to get to the data that's blocked out over here that you can't see. One other thing on your calculator is that if you do need this comma, if you have to enter the data this way and you need the comma key is its own key, and it's found right above the 7. So if you need to use the comma key because your calculator does things a little differently, then you can go straight to the comma located above the 7. And again, please try this on your calculator so that you have an idea on how your calculator is going to do things differently and work them. On your exams, you can use a calculator. I encourage you to use a calculator, but again, I encourage you to make sure you know how to use it prior to going into that test. And we will use it throughout the semester, and I'll try to show you all the different techniques and things that can happen on the calculator as we go. All right. Other sampling techniques. The next one is called Stratify. And this one divides a population into groups, into some sort of strata, and selects a random sample from each group. To collect a stratified sample of the number of people who live in West Ridge County households, you could divide the households into socioeconomic levels and then randomly select households from each level. So it's sort of leveling, giving us one more layer or one more level so that we can really dig deeper into whatever the results of your survey or whatever the results of your questions are going to be based on randomly selecting them. Okay. The next one is called a cluster sample. A cluster sample divides the population into groups or clusters and selects all of the members in one or more, but not all of the clusters. So it's going to take a population. If you look at the example here, there are zip codes. It's going to take those zip codes and it's going to block them off into the 4 different zones. And then from that, it's going to select just one zone, and that would be called a cluster. Again, may not be as exciting. This is sort of like the county example we used earlier. Selecting one county may not give you the answers or the results that you're looking for. Selecting one zone, in this case, may also not work to give you what you're looking for, but it might help certain data. Just depends really on what you're looking for in your experiment. The next one is called a systematic, or systemic, sample. It says choose a starting variable at random, then choose every case member of that. So in other words, you're going to start and say, okay, here's the first one, 86. Then you're going to jump to the next 100 and choose 186, and then 286, and then 386, and 486. So this is similar to the example that I said earlier where you were using like a simulation where you pick every 5th person who walks into the store. So that would be more systemic rather than just random, totally random. And then the last one is called a convenience sample. And literally, this is the one that says you're going to choose members of the population that are the easiest to get. This is also not recommended because it does lead to biased studies. So try real hard not to do convenience. All right, so identifying the sampling techniques. Number 1, you divide the student population with respect to majors and randomly select and question some students in each major. So you divide them into majors and then randomly select them. So this would be stratified. Because you've divided them into groups. And the group is the major. Number 2, you assign each student a number and generate random numbers. You then question each student whose random number is generated. This is your purely random sample. Then number 3, you select students who are in your biology class. If that's all you're looking at are students in your biology class, then this would be convenient. And of course, not the best choice. All right, and that concludes section 1.3, and also concludes chapter 1. So we're going to be working into chapter 2 next.